Hello friends, in this AV we are going to take up the numericals of chapter 6, that is spectrum of ICSE class 10 physics. We would be taking up the numericals of exercise 6A. Here the first numerical says calculate the frequency of yellow light of wavelength 550 nanometer. The speed of light is 3 into 10 raised to the power 8 meter per second. Now here we will be using the formulas that you have learnt in class 9. The formula, if you remember, that the speed of light is equal to frequency multiplied by the wavelength of light. So we are going to use that here. Now here they have given the wavelength in nanometer, so we will have to convert it into meter. Again, these conversions you have done it in the very first chapter of class 9, so we will be using that. 1 nanometer is 10 raised to the power minus 9 meter, so we will multiply this with 10 raised to the power minus 9 and convert it into meter, and then we will proceed. So here I have written the given things. Wavelength is given as 550 nanometer. We convert it to meter by multiplying it with 10 raised to the power minus 9. So we just write it like this. Speed of light is given to us as 3 into 10 raised to the power 8 meter per second. So we will be using the formula which says speed of light is equal to wavelength into frequency, which gives frequency is equal to speed of light divided by wavelength. We have the value of speed of light, we have the wavelength, so we simply put it. Now if you see, we have put 3 into 10 raised to the power 8 as the speed of light, and the wavelength is 550 multiplied by 10 raised to the power minus 9. So 10 raised to the power minus 9, if I write it in the numerator, the minus sign vanishes. So 3 divided by 550 gives us this 0.00545. The number is long, we have taken the round off, multiplied by 9 plus 8, 10 raised to the power 17 hertz. Now what we have done here is we have shifted the point to 3 decimal place. For that we need to multiply and divide by 1000, that is 10 raised to the power 3. So this decreases by 3 and we have 5.45 multiplied by 10 raised to the power 14 hertz. This is the answer. Now the second question says the frequency range of visible light is from 3.75 into 10 raised to the power 14 hertz to 7.5 into 10 raised to the power 14 hertz. We have to calculate its wavelength range, and the speed of light is 3 into 10 raised to the power 8 meter per second. So what we will do here is we will calculate the wavelength taking the frequency as this one in the first case, and then we'll again calculate the wavelength taking the frequency as 7.5 into 10 raised to the power 14. So we will get the value of the range of the wavelength. So here if you check, we have written the given things. Speed of light is 3 into 10 raised to the power 8 meter per second. Then the frequency range is from 3.75 into 10 raised to the power 14 to 7.5 into 10 raised to the power 14 hertz. So first of all we take the frequency 3.75 into 10 raised to the power 14 hertz. For this the wavelength is equal to speed of light divided by the frequency. So speed of light is 3 into 10 raised to the power 8 meter per second, and the frequency range that we are taking is the upper range, that is 3.75 into 10 raised to the power 14. So here this can be written here in the numerator as 10 raised to the power minus 14. So minus 14 plus 8 gives minus 6, and 3 when divided by 3.75 gives you 0.8. So when you again shift the point to 1 decimal place, you get it as 8 into 10 raised to the power minus 7 meter. Now we will convert it to angstrom. So for conversion from meter to angstrom, we have to divide it with 10 raised to the power minus 10. So we will be left here, this minus 10 can be written here as 10 raised to the power 10 in the numerator. So plus 10 minus 7 is 10 raised to the power 3. So 8 into 10 raised to the power 3 gives you 8000 angstrom. Now for the second range of frequency, we write here for frequency range 7.5 into 10 raised to the power 14 hertz. Again, wavelength is equal to speed of light divided by frequency. So we put the values and we calculate. So here again, this 10 raised to the power 14 can be written in the numerator with a minus sign here. 10 raised to the power minus 14 it will be. So plus 8 minus 14 gives you minus 6, and 3 divided by 7.5 gives you 0.4. Again we do the same process. When you shift the point, this 10 raised to the power minus 6 becomes 10 raised to the power minus 7 meters, and to convert it to angstrom we have to divide by 10 raised to the power minus 10. So from meter it gets converted to angstrom. Again you divide, and this comes to be 4 into 10 raised to the power 3 angstrom, which is nothing but 4000 angstrom. So the wavelength range of visible light is 4000 angstrom to 8000 angstrom. So that's all we have in this AV for you. These were the numericals of exercise 6A. Happy learning. God bless.